Do you have any more standing?
No. God. Oh, you should have taken some when you left and kept it. All right, exponents. Okay, listen carefully. If you have something that looks like this, all right, and you dealt with this in Math 97. How do you read this? What's one way to read this? 4 squared, or you could say 4 to the second power. Okay? So remember that now this whole thing is called an exponential expression. Exponential expression. Okay? The 4 is called the base. That's your base. So in my math lab, they're going to ask you definitions like what's the base, what's the exponent. The 2 is called the exponent. All right? So the 4 is called the base, and the 2 is called the exponent. Now, 4 to the second power means this. Means you multiply the base by itself the exponent number of times. So you multiply the base by itself the exponent number of times. So some students, even though we talk about this over and over and over again, on a test or worksheet, they're going to say 4 squared is 8. Because they say 4 times 2. That's not what that means. That's not 4 times 2. That's 4 to the second power, which means 4 times what? 4. Which is what? 16. So 4 squared equals what? 16. Okay? So if you have, and this is where you have to look at the different things that you can see now. So if you have, let's say, 2 to the third power, 2 cubed, 2 to the third power, that means I take 2, the base is 2, and I multiplied the base by itself how many times? 3 times. 2 times 2 times 2, and use the order of operations. 2 times 2 is 4. 4 times 2 is 8. So the answer is 8. Now, what if I had this? Negative 5 squared. Negative 5 squared, what do you think that means? Negative 5 times negative 5, good, which is positive 25. Okay? What if I had this? Okay. Mathematically, there's a difference between the two. There's a difference between the two. In the first one, my base is indicating that my base is what? Negative 5. If there's no parentheses there, the base is only 5. Okay? So the base is 5. So what's being squared? Only what? 5. So what's 5 squared? But I got to do what? Make it negative. So the answer is a negative 25. So there is a difference between these two notations. So if I want the base, if I want the base to be negative, I got to put it in what? Parentheses. Okay, so make sure you know that.
Are you going to ever have a negative in parentheses and have it like cubed or?
Say it again.
Are you going to ever have like a negative 5 in parentheses like cubed?
Yes.
So you'll be negative 5 times negative 5 is positive 25. Positive 25 times negative 25 is negative.
Yes, so you could have negative 5 cubed means negative 5 times negative 5 times negative 5, right? And so negative 5 times negative 5 is 25. 25 times negative 5 is a negative 125? Negative 125. Okay? Now, remember, as you work through this, you're going to notice that a negative number raised to an even power is always going to be what kind of number? Positive.
Maybe I'm doing too, I don't know.
But it's always going to be positive. A negative number raised to an odd power is going to be what? Negative. Yes.
Done to my friends yesterday.
What?
I used to say that negative for the second.
What's a negative times a negative?
Positive.
What's a positive times a negative? There you go.
Yeah, talking about the one without the parentheses.
Mathematically, you got to remember this now. Mathematically, there's no parentheses there. It means the only thing that's being raised to that exponent is the base. The base is only 5, not -5. Okay? All right. Okay, now listen to this. What if you had this? Okay. You see I have that 2 negatives here? Now, listen, guys. This means you can think of that negative out here meaning the opposite. So you can think of this as the word opposite. All right, so listen carefully to what I'm saying. I'm covering this outside negative. What's -2? And -2 is the base, right? What's -2 squared? 4. Okay, I'm going to go ahead and rewrite it. So that part's 4. This says I take the opposite of 4, which is a what? -4. So the answer is -4. Okay? That's all that is.
Didn't you attempt it to multiply a negative times a negative first and make it a...
No, that's not, you don't do that. So her question is this.
That's what it looks like.
No, so don't confuse that with something like the distributive property. Remember how when you had 2x minus 5, remember that? And you distributed the -1, remember that?
Yeah.
Okay. The only reason why you use the distributive property here is because the exponent was a 1 up here. That's the only time you can use distributive property. So this will become -2x plus 5. Don't confuse that with distributing that -1 in here. Don't say, then I'm going to rewrite this as +2. You cannot, because this exponent up here is what? It's not a 1. It's something more than a 1. Okay? So if you had this, then you could say, see how this is a 1? Then you could say -1 times the -2 is a what? +2. But always think of this as the word opposite. The opposite of a -2 is what? +2. The opposite of a -2 squared, order of operations, I do exponents first, right? Mm-hmm. So what's -2 squared? +4. The opposite of a +4 is a -4. Same thing here. I can think of this as the opposite of this binomial. What's the opposite of 2x? What's the opposite of -5? Same thing. All these are related. Okay? All these are related. All right. So we're going to finish this up next class period. All right. Also next class period, we're going to start talking about equations of lines. So what I need for you to do first, though, those worksheets that dealt with those equations, you have to get in slope-intercept form. I need for you to do that because that section where we talk about equations of lines, they're going to ask you to write the answer in slope-intercept form.
Is the equations of lines different than linear equations?
No, they're the same. It's just a different way of writing it.
Oh.
You have to. You also have to find the equation. Whereas you were given the equation, you graphed it.
Yeah.
What's going to happen now is you're going to be given the graph, and you have to find the equation. Seriously. I know you don't like hearing that, but guys, remember, you want to succeed in college algebra, right?
I do.
Okay? So I know you do, Erica, but you got to stop complaining, girlfriend. All right, seriously. You got to stop complaining. You got to take it in stride because you got to tell yourself, I want to get my degree. In order to get, Erica, listen to me. In order to get my degree, I've got to get through college algebra. In order to get through college algebra, I've got to get through this course. And I want to learn as much as I can from this course. So you're going to be excited about that and not complain. You understand? All right. I'd appreciate that, though, Erica.
I love you too.